Okay, for this foldable, you have to, of course, trim around the outside and then trim where the little dashed lines are to make it have these 6 little flaps on the top. So once you've got it cut around the outside and then folded to where you can see the name in the middle like this, you can restart it. Okay, so the first flap up here is vocabulary. So I have a picture. You need to know that the Pythagorean Theorem is only for right triangles, so draw your little symbol for a right angle on there. A and B are legs. C is the hypotenuse. So the hypotenuse is the longest side, and it is the side opposite the right angle. So if you'll draw that arrow that points away from the right angle, you'll never get the C wrong. Okay. All right. The next one says, let's do this one over here. Proving the Pythagorean Theorem. Okay, so the Pythagorean Theorem states that a squared plus b squared equals c squared. So you hear the word squared in this formula whenever we read it, because in truth it's really talking about the area of these squares. Okay, so it has an area of 3 by 3, so this is an area of 9. This side of the square is 4, so 4 times 4, or 4 squared, is 16. And then this one over here is 1, 2, 3, 4, 5. So it's 5 by 5, or 5 squared is 25. Okay, so go ahead and put like a plus right here and then an equal. So 9 plus 16, the area of these 2 smaller squares is equal to the area of that largest square. Okay. Now we'll move on over here to find the missing hypotenuse length. So whenever you are missing the longest side, I'm about to show you the shortcut. Okay, so it says first square the legs, second add the legs together, third take the square root of the answer. You can actually type this all in one step. Okay, but I do want you to write the formula. A squared plus b squared equals c squared. So, shadows. Okay, for A I've got 6, for B I've got 8. So, here's the shortcut. To get C, you can actually just put the square root over all of this. 6 squared plus 8 squared. So you will only want to add them whenever you are missing the longest side, because if I am adding them, I am making it get bigger, okay? So practice the shortcut. If I can get the shadow off the screen. Okay, you're going to do your square root, and you're going to do 6 squared plus 8 squared. And you have magically just solved for the missing side, C, the hypotenuse, okay? So remember, whenever you do the shortcut, if you want to type it in all at one time, if you are missing the longest side, you are going to be plussing, because you're making these sides get bigger, okay? So let's write that the answer right there is 10 equals C. You check to see if it makes sense. You want this to be the biggest number on your right triangle. Yes, 10 is bigger than 8 and 10 is bigger than 6. Okay, moving on. Move right over here. To find a missing leg length, I'll also show you the shortcut to type it in all at one time. So they've labeled B because it's helping form that right angle. So you label A, point it across, and that's going to be C. So if I've got two sides of any right triangle, I will write my formula like a good child. And then I'm going to go fill in numbers. A says 5, B is still B, and C says 13. Okay, shortcut people. Write B squared equals, oh, I should have shown you this step right here. I don't want this 5 squared over here, so I would need to minus 5 squared from both sides. So I can just type this in one long step right here, the square root of 13 squared minus 5 squared, and that will give me B. So whenever you're missing a leg, we still always take the square root, so do that part. Whenever you're missing a leg, you have to type in the longest side. Why won't this work? The longest side first, okay? And then you subtract the leg that you had. You gotta square it because the formula tells me to, okay? So the hypotenuse squared minus the leg will get me the missing leg. I am going to subtract because I need to make that number get smaller, okay? 13 squared minus 5 squared, I'm taking the square root, I get 12. Which kind of sounds weird because it's not much smaller than that hypotenuse. But if I check to see if it makes sense, yep, 12 is smaller than 13, so it works. Okay. Pythagorean Theorem converse. If you are trying to determine if you have a right triangle, you can square all of the sides. If the sum of the squares of the two smaller sides is equal to the square of the longest side, then the triangle is a right triangle. Okay. They're trying to get you to prove that this is a right angle. I know y'all tell me all the time, well, Miss French, it looks like a right angle, so yeah, it's a right angle. Well, you don't really know that. Okay, what if it's like the tiniest bit off? So, but now you have a way you can prove it. A squared plus B squared equals C squared. So, before you ever plug in numbers, you label A, B, over there is C. Okay, so I'm trying to see if this works. Okay, so under my A, I'm going to put 10 squared. For my B, it had a 24 squared. C says 26 squared. So I just need to work each side in my calculator to see if these numbers make the formula true. Okay, so 10 squared plus 24 squared. I got 676. I'm going to work the other side, 26 squared, and I got 676. Okay, so I'm going to write that last step. I worked this and I got 676. I worked this side and I got 676. Whenever you do that and you substitute these three numbers for A, B, and C, and you do get the same number on both sides, that's proving you that, yes, it is a right triangle. Okay. If you got 676 equals 582, then that would tell you that those three numbers did not make a right triangle. Okay. This last part of the foldable here, Pythagorean triples, are just ones that they like to use a whole lot. So if you ever see a triangle that has 3 and 4 for the legs, save yourself the work and just put a 5 because they love to use that one. It's the smallest one with whole numbers that you can make a right triangle. 3, 4, 5. 5, 12, 13. Oh, notice that if I take these and I just double them, so like if I multiply them all by 2, I get a 6, 8, 10. They really like to use that one. What else do I notice? 5, 7, 8, 9. Okay. Yeah, those are good ones to know. Or while you're working some of your practice pages or your Excels, I would have this open so that it can save you some time.